right, so welcome today to the salt chlorine generator training, being sponsored by my company, Space Coast Pool School. And just a little bit about me really quick as I teach I'm a provider of the PHTA nationally recognized CPO or Certified Pool Operator course. I offer in-person courses anywhere within Florida and private classes as well. I do also offer the 100% online CPO course to anyone from anywhere. So you can look me up at spacecoastpoolschool.com, or you can call me Lauren Broom, your moderator today as well at my number's there. So that's a little bit about me as your moderator and your sponsor today, but I want to extremely welcome Sean Assam with AquaCal Autopilot. And I'm going to be handing it off to him. Just give you a little bit, I've known him in the industry, 12, 15 years since we met at the pool show. And he came up, I used to work for the health department for 16 years, left last year. I was a commercial pool inspector for the health department for 16 years and left to do my own business. And he came up and did a training class for my contractors in my county, did an awesome job, gave them great information on salt chlorine generators since we're starting to see them more in the commercial industry as well now. And I've attended his class a couple of times as well at the Florida Swimming Pool Association trade show. So really wanted him to come in, offer this training to anyone that wants to learn more about salt chlorine generators. Residential market, we're seeing a lot more of these, like 85, 90% of our residential pools are now being built, I would say, with these, right, Sean?
Absolutely.
So there's a lot of unique things with this particular equipment compared to all your other pool equipment. So I wanted to bring him in as he's the expert. I consider him an expert in this area, and I wouldn't have asked anybody else to come in. So I'm going to pass it off to you, Sean. I'm going to stop sharing my screen, and it's all yours.
Okay. Good morning, everyone. Thanks for taking your time out. I'm going to go through a presentation. It's kind of generic, covering salt chlorine generators. I can get into more specific manufacturer questions if you do have them. But I'm going to get into how a salt system works, what you really need to do to maintain them, how to troubleshoot and diagnose systems as well. And getting into some other myths about salt systems also. So as I'm going through the presentation, if you have any questions, please feel free to either put a comment in the chat or go ahead and unmute yourself and ask your question. Like Lauren said, I rather address the question when you have it, when it comes to your mind. Or if I know that I've got a slide that's going to cover your question, I'll defer the question till I cover it in the presentation. My name is Sean Assam. I'm with AquaCal Autopilot. There's my cell phone number, my email address if you need to contact me directly. If you do have a specific question regarding Autopilot, or if you have a troubleshooting with Autopilot, the best way for me to help you out is if you can call me on the cell phone when you're in front of the unit on the job. All right. So my information is out there for you to access. Utilize me as a tool or as a resource for your company. So salt chlorine generators has been around for a long time. Let me just cover one more thing. I've been in the industry almost 35 years, mostly with distribution and then into the manufacturing of the Autopilot salt systems and AquaCal heat pumps. All right. So let's get into all right, so this is what we're going to cover today, the basic understanding of salt systems. I'm going to touch on water chemistry because we all are pool industry professionals and we understand water chemistry, but I want to focus specifically on how water chemistry impacts salt systems, and then we'll get into basic troubleshooting. All right, so the first thing is when we look at a salt chlorination system, every single salt system requires a couple of components, right? So you've got the power supply, you've got the cell, and your cell is going to be a couple of different configurations or different designs, and then you've got the pool water. So the first thing is, what do we need to put into the pool? Salt, all right? So we're gonna add salt into the pool. The concentration typically is about 3,000 parts per million. When salt is added into a pool, it dissolves and it stays dissolved. It does not come out of solution unless you've got very, very high concentrations, or your water evaporates and then you're left behind with the salt residue. So we add salt into the pool, it dissolves, it stays dissolved, it circulates throughout the entire system. So as the salt water is circulating through the system, it's going to go past the pump, the filter. If you've got a heater, it's going to go through the heater, and then it's going to go to the cell. Right at the cell, that's where we're generating the chlorine, okay? The concentration of the chlorine at the cell is typically at around superchlorination strength. So you're very, very high on the chlorine concentration within the cell body. When it goes back out, it dilutes back with the rest of the pool water circulating through. It's going to circulate through, and then it's going to go back to the pool. When it gets back to the pool, it's going to react like any other form of chlorine that you're adding into the water itself. It's going to create a residual. It's going to treat the water for any kind of bacteria, germs, and algae and all that stuff, all right? So the salt chlorination process really is, you're generating chlorine. It's just a different method of introducing it to the pool than your tablet feeder, your liquid feeder, cal hypo, or hand tossing chemicals into the pool. You're just producing your own chlorine on site. All right, so that first component, what kind of salt? We have to add salt into the pool. A 99.7% minimum purity is going to be best. Pool salt, any of the labeled pool salts are going to be good because it's granular, it dissolves quickly, and it dissolves quickly, all right? You can also use granular, the salt, the pellet salts, and flake salts are okay, like water softener type salts. Those are okay, but because they're bigger chunks, it tends to take longer for them to dissolve, okay? When to add salt. A lot of plaster pools, they require that you wait 30 days after a newly plastered pool before you add salt. And the main reason for that is because they want to make sure that they're isolating any kind of problems that they may have in the first 30 days of the plaster curing. So what does that mean? On a new plaster pool, a lot of manufacturers will tell you wait 30 days or else you void the warranty, because what happens is if there's any kind of staining, any kind of modeling, or anything to the plaster that takes place, they want to make sure that they can isolate it to either a water chemistry issue or a plaster issue. In this case, if we do not add salt until after the pool cures, then we're eliminating salt as a possible cause for any kind of staining or plaster issues, right? When you add it, you want to make sure that it's circulating for at least 24 hours before you turn on the salt system, all right? Because what happens there is there's a lot of salt systems that cannot tolerate high salt levels. So when you first add your salt, that concentration tends to be on the higher end. So waiting 24 hours for it to circulate gives it time to spread throughout the pool and bring it down to a normal level. So in a pool, in the process of chlorine generation, we're not using up salt to create the chlorine, okay? What we're doing is we're converting the salt through electrolysis to create a chlorine residual. So what does that mean is that we're not going to lose salt. If we add 3,000 parts per million of salt into the pool, as I'm making chlorine, it's not dropping down to 2,500 to 2,400 as you're making the chlorine. So the 3,000 levels should stay pretty constant. How do you lose salt? Backwashing filters, bathing suit drag out, splash out, and leaks in the pool. Okay, so you can see there's a physical loss of water out of the pool for it to lose salt as well. Your normal evaporation does not lose salt. Okay, evaporation is just the water itself that's going to reduce, not the salt level. So in evaporation, what are you doing? You're losing water, salt concentration goes up, but then you top off the pool and it stabilizes back out to what it was before, all right? Concentration of salt that's needed. Like I said, most manufacturers are going to be dealing between 3,000 to 4,000 parts per million of salt, which is in the good range. But a couple of things that you want to do. before you even add salt to a pool is you want to check your salt level in the water first, okay? Reason why I say that, there's a lot of liquid chlorine pools that's being maintained. When you're adding liquid chlorine to a pool, you're adding salt as well, all right? In the state of Florida, we've got a lot of chlorine pools, liquid chlorine pools. And I can guarantee you that a majority of those pools, whether they know it or not, they probably have 1,500 to 2,000 parts of salt in the water already without them knowing it, just from years after years after years of liquid chlorine addition, all right? Typically below 2,000 parts per million will shut off the system. Everyone's system has a low salt cutoff. There are some systems also that will have a high salt cutoff. So be very aware, depending on which manufacturer salt system that you're maintaining or you're going to, that you know what the salt range is for that system. All right, so I'm talking about salt at 2,500 to 3,500 is your typical range for normal operation of salt. How does that compare to some other things? At human taste level at around 3,500 parts per million or higher, you can start tasting salt in the water. Around 6,000 parts per million is contact lens saline solution. The human body is around 9,000 parts per million. And when you're dealing with a salt pool and a homeowner sees you putting a whole bunch of salt in the water, they typically think it's going to taste like seawater. As you can see there, seawater is 35,000 parts per million. So if we're dealing around 3,000 parts per million, we're 1/10 of what seawater is, all right? One of the comments that we hear is that with a salt pool, it's soft and silky water, all right? What happens there is when you add salt to a pool, it becomes closer matched to what our body is, so the water feels different, all right? We know that in the industry, water tends to find its own balance. So if we jump in a pool that has no salt, guess where it's going to try to balance that salt from? From our bodies, all right? So when we jump in the water, it's starting to draw salt out of the body. That's why when you get out of a pool that doesn't have any salt in it, your skin feels dry. It's because of that hypotonic effect of water chemistry trying to balance itself. We hear that salt causes corrosion. Yes, that's true, but not at the levels that we're dealing with. At the 3,000, 4,000 parts per million of salt, it's not going to be corrosive. That 6,000 part per million level, right at the contact lens saline solution, that's 6,000 part per million is where that concentration of salt will be corrosive to stainless steel in the water. All right, so be very aware that check your salt level first before you add salt so you don't get to that 6,000 part per million concentration threshold. All right, this is something that we hear in the industry from the homeowners I don't have a chlorine pool, I've got a salt pool. I'm here to tell you that a salt pool is a chlorine pool. You are producing your own chlorine on site, all right? That's all it is. We're making our own chlorine on site. It is a chlorine pool. Chlorine production, like I said before, the chlorine that's being generated within the cell hits breakpoint chlorination. So that does a couple of things. It does oxidize the contaminants in the water and eliminates, in most cases, your chloramines that's passing through. How does it do it? Well, as the water's passing through, the cell is energized, it's hitting that breakpoint chlorination, it's going to treat the water that's passing through the cell, all right? I want to make that very important. It's treating the water that's passing through the cell. It's creating the residual that goes back to the pool so that you can maintain an algae-free pool, a germ-free pool. But the oxidation and the chloramine elimination takes place within the cell body itself, all right? So one of the questions is, well, how do I know my cell's working? Quick trick to do is make sure that you've got enough salt, activate the cell, let it run for about a minute, and then crack open the union after the cell and take a water sample there and check your chlorine level, all right? So at that point, you should have a much higher chlorine level than what you have in the pool itself. And that's a quick way to see if your cell's generating chlorine. All right, so here is, this is a picture of our convection cell, and there's supposed to be a video link on it, which doesn't appear to be working. So I'm going to skip it, but what it was basically showing you is when a cell gets energized, there's a lot of bubbles that emanate from the cell itself. Okay, so one of the questions is, well, I'm seeing a lot of bubbles go back to the pool. That's a normal process of chlorine generation, is it will generate bubbles. What you're seeing is oxygen, hydrogen, and chlorine gas. But because the chlorine gas is being generated in the water, it gets quickly absorbed by the water to become sodium hypochlorite, liquid chlorine. So the resulting bubbles that you see coming out is hydrogen gas and oxygen that's coming out of the system. All right, so it's a normal process. All right, so the electrical reaction.
Sean, can I have a question really quick?
Yeah, absolutely.
So I know I'm the moderator, but I'm listening to the training as well. So the air bubbles that you're seeing, is that coming out at the cell on the output side? Or
Yes.
is that at the output side? Okay.
Yeah, it generates from the cell, and then, you know, through your return lines, you'll see the bubbles coming out of your jets. Okay.
Got it.
In some cases, you'll see more bubbles coming out of the closest jet to the equipment. One of the ways to minimize that is if you use a smaller orifice on that particular jet, it forces the bubbles to go to the other returns or the other jets, so the bubbles aren't as apparent in that first jet. Okay. All right, so the electrical reaction. Water's conductive, but it's not conductive enough. That's one of the reasons that we have to add salt to the pool. We're increasing the conductivity of the water itself. But it also gives us a basis to make the chlorine, because salt is sodium chloride. Through the electrolysis, we're going to take the chloride component, create a chlorine residual that stays in the water. Okay, a cell requires water, salt, and electricity, or the electrolysis, to generate chlorine. Cell must be clean of scale, and you must limit operation at cold water temperatures. A lot of systems will continue to operate until you hit a certain temperature threshold, and then it shuts off. But as it's getting colder, the thing that you have to remember is that when the water temperature gets colder, your chlorine demand is reduced as well. Okay, so if there's less chlorine demand and you don't make a change to the output of the chlorine generator, it's going to make as much chlorine as it was when it's 80, 85, 90 degrees. But now it's 60 degrees, you don't need as much chlorine. It's still making a high amount of chlorine. All right. So the reason why you want to make sure that you're adjusting the output based on water temperature changes is because your chlorine demand is reduced when it starts getting colder. When it gets to a certain point, like I said, the unit will shut off automatically. I can tell you with the autopilot itself is the only one that will operate under cold water conditions. All right. Let's see what's here. All right, salt to chlorine reaction. Salt is electrolyzed to split the sodium from the chloride, but quickly recombine. So what does that mean? If you take sodium chloride, salt, right? Through the electrolysis, it's going to separate the sodium from the chloride. You got the chlorine that's going to the pool as a chlorine residual, but it automatically recombines. And that's what I've talked about before. If I've got 3,000 parts of salt, as I'm making chlorine, I'm still going to have 3,000 parts per million of salt. The salt itself is not sacrificed to make the chlorine. All right, so chlorine gas is produced in water, which instantaneously converts to 100% pure sodium hypochlorite. The big difference between the chlorine that we're manufacturing and the packaged chlorine or the liquid chlorine you get from pool stores is that your typical sodium hypochlorite is about 12% strength. We're at 100% strength because we're making the strongest form of chlorine gas, which is right in the water itself. Okay, so it converts and it becomes sodium hypochlorite. Sodium hydroxide is a byproduct which increases the pH. You tend to see on a salt system the pH is going to rise. It's going to rise to about 8.3, 8.4, because that's the nature of the chlorine generation. The way that you can reduce that pH rise is by making sure that you size the system properly. A lot of residential salt systems are based on 20,000, 30,000, 40,000 gallon sizing. In my opinion, it's always best to oversize the salt system. And the reason why is because the more that you kind of just borderline size it, let's say you have a 20,000 gallon pool and you put a 20,000 gallon system on there, that's fine. But just keep in mind that you're typically going to be running it at a higher percentage output, which means the cell is going to stay on for a longer period of time. The more that the cell stays on, it impacts that pH. All right. So the more the cell stays on, the quicker that you're going to see that pH rising up above 8.0 to 8.3 to 8.4 range. Okay. Oversizing allows you to run the output at a much lower output, which means your pH will be more stable than the quick pH rise. All right. pH rise is also dependent on the pool finish, your source of the pool water, and the amount of chlorine that's needed. The amount of chlorine needed goes back to that percent setting on the salt system. So again, the higher the percentage that your salt system is set on, the faster you'll see that pH rising. Okay. For outdoor pools, stabilizer is absolutely recommended. We want to make sure that we have protection from the sun. All right. For indoor pools, stabilizer is not needed. Recommended salt level, if you've got any kind of ORP controller, like on a commercial pool, 30 to 50 parts per million is what's recommended. If you do not have an ORP controller, I like it up at around 75 parts per million. Okay. Does not eliminate the need to maintain your pool. A chlorine generator is not a do-it-all, take care of everything. Okay, it doesn't take care of everything in regards to your pool. So what you need to do is, just like you normally would, you you got to test your water periodically. You've got to make sure that all your chemistry levels are good. And we're going to get into also talking about, you know, the water chemistry itself, like this particular chart here. We all have our max and minimum ranges, acceptable ranges that we want to make sure that our water chemistry is staying in between. And that's all fine. That's what we want to do on a day-in, day-out basis. But then you also want to look at not just what your chlorine level is, not just what your pH level is, but there's one other thing in regards to, all right, so getting back to water chemistry. On our water chemistry, I think we all like to have a certain range that we want to maintain. What's important with chlorine generator systems, and why a chlorine generator system really requires you to go one step further, is because when we look at what impacts our chlorine generation process or the cell itself, is scale formation. When you've got calcium scale on the cell, it reduces the chlorine production's capability. It reduces the life of the cell also, okay? So those are specific reasons why we want to go one step further than just checking for chlorine and pH. We want to get into alkalinity. We want to get into calcium hardness and calculate and see what our saturation index is, okay? There's not a lot of people that check for the saturation index, but especially with a salt generator system, the saturation index tells us if our water chemistry is balanced, if it's scale forming, or if it's corrosive. That scale forming part of the water chemistry will develop on the cell, and it will cause a lot of issues with chlorine generation and the longevity of the cell itself, okay? So if we get into this chart here, we can see what our minimum maximum ranges are for those chemistry levels. We can see the column with the chlorine generator, in that the chlorine, free chlorine itself will generate to whatever level you want to maintain based on whatever percentage you set it to. The pH level is 8.2 to 8.4. All right, total alkalinity, we have no impact on the alkalinity. We have no impact on the total dissolved solids, other than we're going to add 3,000 parts of salt. So when you test for TDS, you will see that as part of your TDS test is the 3,000 parts of salt. Calcium hardness, we have no effect on calcium hardness, and we have no effect on stabilizer. When we look at that compared to some of the other traditional forms of chlorine, all right, so that first row across is your salt chlorine generator. We have very little impact on the rest of your water chemistry. When you're using liquid chlorine, 10 to 12% strength, you've got a 13 pH. That 13 pH is going to increase your pH, increase alkalinity, increase TDS with no impact on cyanuric acid. Trichlor tablets, which is the second form or most common form of chlorine, you've got a very low pH of 3.0, which is going to lower pH, lower alkalinity, increase TDS, and increase cyanuric acid. So you can see the other impacts as well as with the calcium hypochlorite, sodium dichlor, or bromine, if you use any of those. All those errors are showing you that all those traditional forms of chlorine or sanitizer that's being used will impact your water chemistry as it shows on there. Whereas when you're using a salt system, it has very, very little impact over the rest of your water chemistry. All right?
Sean,
Yeah.
can I ask a question really quick?
Yes.
So when we go back to TDS with salt systems, I know that the recommendation is once you get to 1,500 parts per million, your startup level TDS, that you would partially drain a pool and refill. But I know with salt systems, you mentioned that 3,000 or whatever you add to the pool, that's counted toward the
salt system. Has very, very little impact over the rest of your water chemistry. All right.
Sean,
yeah.
Can I ask a question really quick?
Yes.
So when we go back to TDS with salt systems, I know that the recommendation is once you get to 1,500 parts per million, your startup level TDS, that you would partially drain a pool and refill. But I know with salt systems, you mentioned that 3,000 or whatever you add to the pool, that's counted toward the toward that TDS level for startup, correct?
Yeah, that's correct. That's correct. So what you want to do is you still want to test your tap water TDS. You want to account for somewhat some parts of salt that you've added. And then typically if you're, let's say you're testing 4,500, you take out the 3,000, right?
Mm-hmm.
With that 1,500 parts of salt.
Got it. Right. Thank you.
Okay. All right, so basic understanding of water chemistry, pH, alkalinity, calcium hardness, water temperature, cyanuric acid. Those first 4 bullet points basically lead to the saturation index. It's talking about what impacts your water balance itself. Saturation index, a quick way to test it is using a watergram if you've got a typical Taylor test kit. And there are a lot of applications online that you can download also that allows you to check the saturation index. And then I'll talk about the effects of imbalanced water. So why is it important? Fewer issues, because when we look at the saturation index and why it's so important is that even if you don't have a salt system, checking your saturation index at least once a month is going to prevent issues. So if your water chemistry tends to be on the corrosive side, which means pH, alkalinity, calcium hardness, water temperature, when those numbers are on the lower side of the acceptable range, you're dealing with corrosion issues. And when they're on the higher side, you're dealing with scale forming issues. Okay, it's where you want them in the middle is where you're going to be dealing with balanced water conditions. That's the main thing. Using less chemicals means more money back into your pockets. Okay, when you're out of balance, you're going to see equipment failures. You're going to see issues, especially on the scale forming side. That's what impacts us. Is a scale forming side allows that cell to build up within the scale builds up within the cell and reduces the chlorine production. Okay. All right, so lower cost of maintenance, like I said, if you're maintaining your pool with balanced water conditions, it's going to cost you less overall. And you've got healthier water when you're dealing with balanced water conditions. All right, so what happens within the cell when you're dealing with unbalanced water? Water chemistry parameters, even if all your water chemistry parameters are within the acceptable range, pH, alkalinity, calcium hardness, water temperature, if 2 or more are on the high side, you tend to have scale formation. Like I said, the first place that you're going to see the scale buildup is within the cell itself. Okay? When it starts getting a much higher condition or much more scale forming condition, or for a longer period of time, you're going to see that scale building up on the tile line, could be on your surface itself as well. All right, so the scale forming condition is not good, but in regards to a salt system, it's terrible because it reduces chlorine production and shortens the life of the cell. All right, high calcium hardness in itself is not a big problem. All right, Phoenix, Arizona tends to have a lot of high calcium issues. All right, so we've got a lot of salt systems in the Phoenix area, and the way that a high calcium issue is addressed is by maintaining lower alkalinity, lower pH. Okay, so when you look at saturation index, you'll see how all those 4 parameters will fit into balanced water conditions. Okay, here's a saturation index formula. Your pH that you test plus a calcium factor, alkalinity factor, and a temperature factor minus 12.1 should equal 0. The closer to 0 you are, the closer to perfect water balance that you've got. When it becomes a negative number, it may cause corrosion. So now you're on the corrosive side of your water balance, which can affect your impellers, any kind of stainless steel fittings that's in contact with the water. Anything metallic that's in contact with water can experience corrosion as a result of just improper water balance. If it's a positive number, you may form scale. The larger the number, the more corrosive or more scale forming tendency that water is going to be. Your acceptable range is plus or minus 0.3. Okay, that's where I want to be, is within that range for balanced water conditions. When you start getting higher than that, then you start seeing that scale formation on the cell. All right, so here's an example. pH of 7.8, calcium hardness 400, alkalinity at 120, all right, with water temperature of 86. Now, all those numbers there fall in line for acceptable ranges for your water chemistry. So let's take a look at how it's going to impact the saturation index. Calcium hardness at 400, your calcium factor is 2.2. On the alkalinity, it's between 100 and 150, so we'll just take a number in between there. Temperature at 86, we'll take a number between the 84 and 94 degrees. Okay, so if we plug in those numbers into that formula, all right, 7.8 plus 2.2 plus 2.0 plus 0.7 minus 12.1, we get a 0.6. That number being a positive side, more than plus or minus 0.3, tells us that that water chemistry is going to be in a scale forming side, and that scale will build up on the cell, and it will impact how much chlorine that's being generated. The Taylor watergram, as you see there, is also another way of checking your saturation index, and it gives you a quick reference as to what your water balance is. Okay, and then again, you can go online and you can download a couple of apps, 99 cents for an app. You know, there's some of them that are free. I think most of the apps you'll see now are going to be free apps. They're real easy to use. Just test your water, plug the numbers in, and it'll tell you if your water chemistry is balanced or not. The one thing that I do recommend is when you're taking your tests, don't use test strips, because test strips don't give you quite the right parts per million results that you need in order to calculate your saturation index. All right, so with every salt system, you're going to find that there are 3 main components: your power supply, your cell, and then some kind of flow protection. All right, so we're required to have either a flow switch or what's called a gas trap for flow protection. On power supplies, there's a bunch of different designs on the power supplies. You'll see that they typically have a digital type display on it. Bottom right corner is the power supply. The display itself is directly on the cell itself, but in any case, you've got a power supply that's creating a low voltage DC that's going to the cell. Okay. Power supply takes 220 volts or 110 volts converted to low voltage DC that goes to the cell. It allows you to adjust the percentage output going to the cell, and that determines how much chlorine that you're generating. It's also going to give you warning lights to tell you if the salt level is good, or if it's low, or if it's high, and if you've got sufficient flow or not. Okay, so the warning lights, when you start getting into troubleshooting, the warning lights basically gives you a direction where to follow to see what the problem is. Okay, so that's pretty much what you're going to see in the power supply itself. Can a power supply create issues with the salt systems? Absolutely. If it's not working, correctly, or if the circuit board isn't functioning properly, it's going to let you know that the system is not working properly. All right, so electronic controller interfaces. Some of the systems will also communicate with IntelliTouch, an Aqualink, those type of electronic control systems. When you are interfaced with those systems, it typically gives you the control of the output level, so you can adjust the output between 0% to 100%. It tells you what the salt level is, and it gives you warning lights, so it gives you the messages if there are issues with the system. When you're troubleshooting, it also allows you to override your electronic control system so that you can go through your diagnostics, okay? And then the other thing is make sure that it's wired properly, especially when it's trying to talk to an electronic control system. It's typically a four-wire communication, an RS-485 communication. You want to make sure that you've got the correct color wires into the correct position, so it'll communicate back and forth properly. All right, so the other second component is your plumbing components, which is going to be your cell. As you can see here, there's a couple of different designs on cells. Top left corner is your typical Hayward turbo cell. The turbo cell is called the turbo cells because it creates turbulence going through the cell, which is supposed to help keep the cell clean of any kind of scale information. Bottom left is your Jandy 3 ports. Basically, you're going to be using 2 of the ports. The third port is where your tri-sensor goes in. In the middle is the Autopilot commercial manifold, which has multiple cells. Top right is going to be the IntelliChlor, which everything is in the cell itself. If you just have the small power supply on the wall. Then the bottom right is your Autopilot residential manifold assembly. Similar to the picture in the middle with the multiple cells, the manifold design is made so that you can control the flow that's going through the cell. Because one of the things that we found with that design is that when you slow down the flow going through the cell, you actually create a more effective chlorine, or you impact the water much more effectively, right? So just like if you understand ozone generators work effectively because it has more contact time with the water. So the manifold design allows more contact time with the water going through the cell by slowing down the flow. So that should increase the efficiency of the system compared to the straight. All right, so the cell generates chlorine, controls chloramine, superchlorinates water that's passing through the cell. As I mentioned before, the sodium hydroxide increases the pH about 8.4. The more the cell is on, the more effect on your pH of your water, okay? So as I suggested before, always try to oversize if you can, because it allows you to run at a lower percentage, and that has less impact on your pH rise. All right, so when we're troubleshooting related to flow, let me just look at something real quick. Okay, so when we're troubleshooting related to flow, like I said, one of the things that we have to be aware of is that if there's insufficient flow going to the cell, remember we're making chlorine, we're making hydrogen gas, we're making oxygen, right? So if there's insufficient flow going through the cell to evacuate those gases that's being generated, that hydrogen gas can accumulate, and accumulation of hydrogen gas can cause a combustive reaction. So that's what we want to avoid. And that's a primary reason that there's a flow switch in every salt system, all right? So flow-related issues, when we look at flow-related issues, there's a whole bunch of non-salt related issues that can cause no flow going to the cell. On the suction side, you've got cleaners, suction side cleaners, pump basket, skimmer basket, valve positioning that can reduce the flow that's going through the system. Pump flow itself on variable speed pumps, if you're running at too low of an RPM, that may not activate the flow switch, so you have to be aware of that. On the discharge side of a plumbing system, you've got your filter that can get dirty, your valve positions again, just the hydraulics of the system creating a lot of back pressure can have issues with your flow switch. Heaters, you've got bypass valves on heaters, and there's always a chance that there's a scale accumulation within a heat exchanger itself that's causing restriction on flow. And then in regards to a salt system, the cell can get scaled up. That will reduce the flow that's going through the system as well. In some pools that are designed with in-floor cleaning systems, those can cause flow-related issues as well. All right. So the impacts of conductivity, here are the three main things that we see that take place in regards to salt systems. Insufficient flow, cells not saturated with water. I just showed you a slide with a lot of different things that can cause insufficient flow to the system. If you've checked all those different reasons, all right, and you're still having a flow related issue, then you can go to the salt system and check and see if the flow switch is working properly. In regards to salt levels, low salt levels will shut it off at a certain point. But when you're coming off of what you would normally maintain, let's say 3,000 parts of salt, as the salt level starts reducing, it impacts the amount of chlorine that's produced. So when you're losing salt and you don't know it, there's a tendency for you to go out and increase the output percentage, not realizing that you're low on salt, and that lower salt level creates less chlorine itself, okay? High salt levels, on the other hand, will also create issues in that some power supplies cannot handle the high salt levels. What the high salt level does, it increases the conductivity of the water. It forces the power supply to run hotter. So rather than letting it run hot, there's a protection feature that will shut it off instead of letting it run hot. Okay, so just be aware that high salt levels can shut down the system also. Water temperature, as your water temperature starts getting cold around 60 degrees, a lot of systems will start shutting down. 50 degrees typically is your limit where you don't want a lot of chlorine generation operation to take place, because under those conditions, you are wearing out the cell prematurely. If you reduce the output down, if it's still operating, that's the best thing for it. In warm water conditions, no issues at all. Warm water actually creates better connectivity in the water as well. All right, so troubleshooting in regards to the cell. When we look at what goes on with a chlorine generator system, we want to make sure that, first of all, our salt level is correct, okay? When you've got proper salt levels, the unit's going to want to make chlorine when it's, scheduled to. Water temperatures, warm water temperature is good, cold water temperature is not good. Scale formation, why does it scale up? We talked about the saturation index, okay? A cell is going to scale up for one of two reasons. Under normal condition, everyone's system, we call it a self-cleaning cell, because what it does, it's a system of reverse polarity. The electrical polarity direction reverses direction about every hour and a half to 4 hours, depending on the manufacturer. But why does a cell scale up? The first one is that saturation index. Anytime you come across a cell that's scaled up, you always want to check your water chemistry and check the saturation index, okay? Typically, when your water chemistry is out of balance, you'll see the cell scale up in 2 weeks or longer. If it scales up in 2 weeks or less, the typical reason is because your power supply is not doing that self-cleaning feature as it should. Okay, so now there's a power supply issue that's not going through the reverse polarity. Okay, so 2 weeks or longer, water chemistry related. 2 weeks or less, it's typically power supply related. All right, or a combination of all the above. Those are going to create problems with the system itself. All right, so the most common problems: low salt, cold water temperature, scale cells. Depletion of a cell. When does the cell need to be replaced? Every manufacturer is going to give you an acceptable amps and volts that the cell should be operating between. When it falls outside of the range, that's when you know there are problems, okay? It'll get to a certain place where, like on an autopilot cell, when I'm hitting 29 volts or higher and my amperage is lower, that's when I know the cell needs to be replaced, okay? So according to the manufacturer, you should find out from them what their acceptable amps and volts are to determine if a cell's good or not. One of the other things that you can tell with an autopilot cell, because you can see the edges of the blades inside the cell. Typically on the two outside blades, those are the ones that's receiving the power coming into the cell. So those two outside blades, when the cell starts to wear out, you'll see the leading edge of the blade start to deteriorate, okay? So what's happening is the electrical reaction going through the cell is actually chewing up the edge of the blade, and that coincides with the life of the cell. So as it starts eroding on the ends, the blade itself is making less and less chlorine. All right. This is what it looks like inside of a cell when a cell gets scaled up. This is easily cleaned off by the self-cleaning feature. When it reverses polarity, it'll clean that scale back off. When you start getting into a position like this, where it's bridging between the cells, that's where a cell is being neglected. Goes back to, is it saturation index that's allowing that scale to build up, or is the unit reversing polarity correctly? All right. So if you clean this cell off, all right, you don't want to see any kind of scale between the blades itself. You can put it back into service. If it scales up again within 2 weeks, now you know your power supply has issues with the reverse polarity, the self-cleaning feature. If it scales up longer than 2 weeks, then you know you've got to adjust your water chemistry to balance water conditions. When you see something like this, it's been neglected for a while. I can tell you when it's that thick on there, even after you clean it off, you pretty much compromise the life of the cell. It's greatly reducing the life of the cell when it's running in a scaled condition and not cleaned off, okay? And in something like this, you're probably gonna see a flow light come on, and you're probably gonna get a much lower amount of chlorine that's being produced into the pool, okay? Don't let it get like this. So cleaning the cell. Manufacturer's instructions will call for a diluted mixture of muriatic acid and water. Please don't use sulfuric acid. It's a different type of acid, and it's not as good as muriatic acid when you're acid washing a cell. Some manufacturers will have cell cleaning kits or tools. If you don't have one of those type of cleaning kit, use a bucket tall enough to house the cell. Soak for about 15 to 20 minutes, rinse, inspect, and repeat if you need to. One of the things that you want to make sure is that you completely dry the contact terminals, the electrical connections, before you put anything back together or plug any electrical cords back on together, all right? Because anytime that you leave it in a wet condition and you put electricity through there, electricity and water doesn't mix very well, okay? It'll short circuit, it'll corrode that contact point. So make sure it's completely dried before you put it back together. With a lot of systems, you'll see that you can either put like a rubber test plug or clean out plug into the cell itself instead of finding a bucket, putting a lot of water and acid in there, and then soaking the cell. If you just plug off one end and put your acid and water solution into the cell, that's a quicker way of cleaning the cell using less water and acid to clean it off. All right. The bottom in red, do not use anything metallic. Do not scrape the blades. Anything that you do that will scrape the blade can compromise the life of the cell. All right, because if you look at inside of a cell, you've got a whole bunch of blades. Those blades are titanium. The titanium itself is impervious to any kind of chemical attack. On the surface of the titanium blade is a coating that's called ruthenium oxide. Ruthenium oxide is a precious metal coating, and that's the coating that sacrifices itself for the chlorine generation process. So anything that you do that's metallic that'll scrape that ruthenium oxide coating is going to allow water to get into the titanium. It's going to get underneath the ruthenium oxide coating and cause delamination, cause premature cell life in your cell. Okay, so do not scrape it with anything metallic.
Sean, we do have a chat box question from Rick. Thank you, Rick. It's Rick asked, can the scaled condition be identified without cell removal, and how do you check it generally?
One of the effects of scale formation on a cell, and this goes back to, like I said, find out from the manufacturer what the acceptable amperage and voltage range is. When the scale formation builds up on a cell, you tend to have less conductivity in the water, which forces that amperage and volt to kind of fluctuate out of the normal range. Okay, again, in regards to an autopilot, my voltage is going to increase and then amperage will decrease. So I know that when the voltage increases, it's going to be as a result of scale cell, cold water condition, or low salt levels. Okay, so there not a lot of systems will give you a warning light specifically for a scale cell condition. Any of those three conditions, right? Scale cell, cold water, low salt levels will kind of encourage you to take the cell out and inspect it. Okay, so that's when you know to look at the cell to see if there's a scale issue taking place. All right. All right. So troubleshooting, and this goes back to the very start of my presentation. If you can call me when you're in front of the system, that's the quickest way that I can help you through diagnosing a salt system. Most calls can be handled over the phone. Most are not related to a defective component. And by using your diagnostic lights and messages, that's the quickest way to walk through what a problem might be. All right, the diagnostic lights and knowing what the amps and volts are is going to be the quickest way to root down to what the problem might be. Most common issues, again, I'm going to say it again, low salt, cold water, scale or failing cell. Okay, I think I've mentioned that at least 5 times. So guess what? What's the most common problems that you're going to see with salt systems? Cold water, low salt, scaling cells. All right. So if you receive a call from a homeowner saying, hey, I think my salt system's not working properly, here are typical questions that I ask. First of all, I'll say to you, if you're going to be out there, can you call me when you're standing in front of the unit? Are there any warning lights on the power supply? Is the cell clean of any kind of scale or debris? What's your salt level? Do you have enough flow going through the cell? Those are your normal operating parameters for a salt system to work properly. So, all right, so we have to establish, first of all, that you've got the right parameters for the cell system to be working properly. When we look at equipment sets and they're describing to us, oh yeah, I mean, the pool guy put it in, it looks great, and you know, everything should be working fine. I feel the water pressure coming back to the pool, so I can't imagine why it's showing you a no flow situation, right? So this is what you, in your mind, this is what you're visualizing, but then you get out there and that's what you see on site. So it's a big difference between what they're trying to describe to you and what you may see when you end up going out to the job site, all right? So some of the issues that we're going to come across. All right, so the first one is going to be low chlorine challenges. And by low chlorine challenge, what I mean is there are no warning lights on the system, but they're telling you that I can't get a chlorine reading in the pool, all right? So the first one, distance to the pool. When we're talking about not getting a chlorine reading with your test, make sure that they didn't add anything for like an algae treatment for either a yellow or mustard algae treatment, because those typical treatments contain sodium bromide. Sodium bromide going into a chlorine generator pool will cause problems, all right? And this is something they may not let you know. If you're servicing the pool, they may not let you know that, yeah, I threw a bottle of this in, you know, until it's too late and you find out that you can't get a chlorine residual test on there. So I always ask, did you treat it for algae lately? If you did, what did you use? And just try to get to the, like I said, try to root it down to what may be causing the problems. Your typical copper-based algicides is not a problem. It's a sodium bromide-based algicides that creates the problems. Chlorine neutralizer, sodium thiosulfate. Chlorine neutralizer is typically used with commercial pools. A lot of times when your chlorine is too high, you would add some chlorine neutralizer to bring it down. Chlorine neutralizer is very effective. And when you look at a jar of chlorine neutralizer, the sodium thiosulfate, it comes in little small pebbles, and it tells you to add a certain amount of ounces per gallons of water to bring it down a certain level, okay? I guarantee you that 99% of the pool industry does not walk around with a scale with them to measure out how many ounces they're adding to a pool. So what happens? I'll throw a cap full and see how that does, you know, or get an estimate. I've got an 8-ounce jar, it says 4 ounces. I'm gonna throw in what I think is half a jar. If you put too much, that sodium thiosulfate will continue to eat chlorine and eat chlorine and eat chlorine. So when the chlorine generator is trying to make chlorine, it's getting consumed by that sodium thiosulfate, the chlorine neutralizer. All right, so those are 2 easy questions. Did you add anything to the pool? If you did, what did you add? All right, pool conditions. So in regards to water chemistry, one of the things that we hear about lately is phosphates create a lot of problems. And then you've got another segment of the industry that says, I've been dealing with pools with very high phosphates for a long time. It's never been a problem. So I like to ask this question. When did phosphates become an issue? In my opinion, phosphate became an issue when they came out with phosphate test kits, right? So now that we have a way to test the phosphates in the water, we know it's an issue. We can sell them phosphate treatments, okay? But the reality with phosphates, how do we get phosphates in pools? Phosphates get in the water by way of your normal water fill, because the cities add phosphates to the water to prevent corrosion in their pipes, any kind of metal pipes. Phosphates will actually coat the pipe to prevent any kind of chemical attack on it. Phosphates can be added into the pool by way of fertilizer. If you're close to a golf course or where they're fertilizing the grass all the time, that fertilizer will get airborne and get into your pool, and that's throwing phosphates into the pool. Okay, anything organic, anything green, leaves, grass clippings, anything that's getting into the water itself that starts deteriorating is introducing phosphates into the pool. Okay, so on the one side where they say I've been dealing with pools with high phosphates for a long time without any issues, I agree with them. It's never been an issue because way in the past, before we had phosphate test kits, the solution would be shock the pool. They got the problem next week, shock the pool again. We never had phosphate treatments to sell to get rid of phosphates, okay? So now that we've got the phosphate treatments, we can sell them a solution for phosphates. What does phosphates do? Phosphates are an algae food source. So when you've got phosphates in the pool water, now you've got a tendency for algae to grow or to thrive in. The higher the phosphate levels, the more food algae has, okay? Even if you've got proper chlorine levels in there, there's still a place where phosphates can allow algae to grow. Dead spots in the pool, right? If you don't have good circulation in the corners of the pools, you're not gonna have a good strong chlorine level over there. If you have high phosphates, guess where the algae is gonna start showing up? Right in the corners of the pools or wherever you have a dead spot, okay? So eliminating phosphates is a good idea. It does help reduce the tendency for algae to grow. But how does phosphates impact chlorine generator systems? All right, so I talked about before on the inside of the cell, we've got the titanium blade with the ruthenium oxide coating. It's a metal blade. Why do cities add phosphates to their water? To coat the metal blade, to coat the metal pipes. With a chlorine generator cell, that phosphate is going to want to coat the blade. So what does that do to my system? It reduces the efficiency of the system. It reduces the amount of chlorine it's going to produce, all right? So phosphates in itself, yeah, you can have a pool. If you have no visible algae, phosphates is not going to create too much of a problem. It will tend to coat the cell, but you still will be able to make chlorine. High phosphates, visible algae, you've got to treat it to get rid of the phosphates, okay? Now, in the process of treating algae with a high phosphate pool, which do you treat first? Do you treat the algae first or do you treat the phosphates first? My suggestion is treat your algae first, okay? If you treat the phosphates first and get rid of phosphates and then you treat the algae afterwards, when you're brushing, after you kill the algae and you brush the algae, guess what you're doing? Releasing phosphates back into the pool, okay? So if you treat your algae first, shock, brush, vacuum to waste, then treat your phosphates, you've eliminated the problem scenario with the high phosphates and algae scenario, okay? Nitrates is similar to how phosphates are introduced, but not as bad. Nitrates is mostly from urine, sweat, from animal pooping in the pools, and from fertilizer also. Unfortunately, there's not a nitrate solution that you can add to the pool to get rid of it. So if you have high nitrates, the dilution is the solution on that one. Low stabilizer level. If you're dealing with an outdoor pool and there's very low stabilizer, your sun can be eating up the chlorine just as quickly as it's being produced. All right, so make sure that you've got sufficient stabilizer in there. And a good rule of thumb is after your initial dosage of salt, whenever you need to add more salt into the pool, there's a good chance that you need to add more stabilizer as well. Because the way that you lose the salt is the same way that you're going to lose stabilizer out of the pool. Then going back into water chemistry, your water chemistry imbalance can create issues with low chlorine in your pool, such as if you don't look at your pH is going to be high. Your chlorine is much less effective or effective with high pH conditions. So again, your tendency is, I'm not getting a chlorine reading, let me just turn the output up to try to compensate. Okay, so you always want to check these conditions, make sure it's not a water chemistry related issue, make sure it's not additions to the pool. And then the next section is the operating conditions of your salt system. You want to make sure that the percentage setting is set correctly for the chlorine demand of your pool. If you've got a pool that gets very little usage, you can set it at a certain percentage, and that's good, right? Day in, day out. It'll maintain the chlorine level that you want to maintain. When you start getting into, the pool's being used more regularly, especially like this summer, everyone's at home, COVID, everyone's using the pool more, there's a higher chlorine demand on the pool at that time. So with the higher chlorine demand, you want to make sure that you adjust the output to compensate for the higher chlorine demand. Short pump run times. A lot of times over the winter time, because it's colder, there's a tendency to think, well, I don't need to run the pump 8 hours a day. I can run it 6 hours or 4 hours a day. If you're running it at a shorter period of time, it means the generator, chlorine generator, is also running for a shorter period of time. Okay? So make sure that the pump is running long enough so that your chlorine generator has enough time to make the amount of chlorine that's needed to maintain your pool. And then the cell being too small. Sometimes we start looking at what is it going to cost. Let me get the cheapest one that I can get. I've got a 20,000 gallon pool. Let me put a 20,000 gallon cell on there. That's fine, but keep in mind that if I say it's a 20,000 gallon cell, that's based on 24 hours a day operation running at 100% with ideal conditions. Okay. Residential pool, how long are we running it? 8 hours a day, right? So that 20,000 gallon system running at 8 hours a day now becomes a 12,000 gallon system or 8,000 gallon system. So that's what you have to consider. Make sure that the cell is sized properly. Other issues that we see, corrosion, like I talked about before, one of the things with salt system is we tend to hear that chlorine generators cause corrosion. As you can see the picture with the standoffs for the diving board, it can cause corrosion. If you live anywhere along the ocean front, anything metallic you can see has oxidation or corrosion on it. It happens with salt systems. And the fact is, like I talked about with the slide on the salt, when you get to 6,000 parts per million or higher, it will be corrosive to metal. So where does the splash out water become corrosive? When the water starts evaporating, right? In the pool, we're at 3,000 parts per million. It's not corrosive. You take that water and splash it out onto the deck or onto, something metallic. As the water evaporates, that 3,000 parts per million of salt becomes 5,000, 6,000, 8,000, and your concentration increases, and that's where it becomes more corrosive, right? Corrosion on equipment, handrails, and ladders. Dissimilar metals such as stainless steel filters, anchor cups, brass anchor cups with stainless steel handrails, those are dissimilar metals that can cause corrosion just by itself, not as a result of salt systems. Fortunately, with our industry, there's been a whole series of specialty components for salt pools. Shaft seals are designed for salt pools. Gas heaters are now coming out with a salt pool heat exchanger. Okay, titanium heat exchangers are pretty much impervious to any kind of chemical attack. So you don't have to worry about with heat pumps, we're all titanium heat exchangers. But in regards to your other equipment, if there's a salt option, that's a good thing to do. That next bullet point talks about bonding equipment. A majority of corrosion issues are as a result of a pool that's not properly bonded. Okay, and what does that mean? Remember I talked about water's conductive, but it's not conductive enough. That's why we add salt. Okay, so now what I've done is I've increased the conductivity of the water itself. When we go down to that last bullet point there in bonding equipment, if the pool's not properly bonded, anything that's electrical in contact with the water, albeit a salt system is low voltage DC, there's a tendency for that electricity to radiate out into the pool, trying to find a way to discharge. If the pool's not bonded properly, it's going to try to find a source of discharge, which is anything metallic, handrails, light rings, ladders, stainless steel anchors, you know. So it's looking to attack those things. When it's properly bonded, it discharges safely by way of that electrical bond, okay? So sacrificial anodes are offered to the industry as a way of trying to protect salt damage. Now, when we look at bonding issue, if there's a bonding issue, the bonding issue's got to be corrected, okay? A sacrificial anode is not the correction for a poorly bonded pool. And the reason why I say that, a sacrificial anode is only there to as a Band-Aid or as a diagnostic tool. If that sacrificial anode starts deteriorating, you've got a bonding issue. And the reason why you're going to see the deterioration of a sacrificial anode is because it's typically a softer metal than your brass, copper, and stainless steel. So when you see that deteriorating, it's because that electrical charge that's in the water is looking to discharge. It doesn't have electrical bond, so it's going to try to find that soft metal first to attack. Okay, so it's a great tool to let you know that you've got electrolysis issues, but it's not the solution. The solution is make sure on the grounding rod on the bottom bullet point, make sure that that grounding rod is properly placed into soil. Okay, not sandy soil. You got to get into dirt down deep enough so that the bond can electrically discharge into the earth. Okay, another source of electrolysis is utility company bonding grid. A lot of times it may not be your customer's pool. It may be the neighbor next door that's got a bad electrical bonding grid that travels through the soil or through the earth to your customer's pool. Okay, so once you've done everything that you can to see if your customer's pool has any issues, then what you need to do is get the utility company involved and say, I've got some kind of electrolysis issues, and they should check their bonding grid, okay, within that whole neighborhood itself. All right. Other issues, like I talked about before, a lot of times what we hear with salt system, it corrodes everything. This is a University of North Carolina pool that we did our salt system on, and you can see stainless steel, the stainless steel lifeguard stand, the handrails. There's a lot of stainless steel in there, all right? So if there's any kind of corrosion issue, there's a lot of water splash out. As you can see, it's a competitive pool that you should see corrosion on the metals, right? On the left-hand side, you've got the light ring, you've got the lane anchors and such, ladders. There's no corrosion on it. But in the equipment room, if you look at the bottom right corner picture, that's cast iron, flanges, fittings, everything in the equipment room was corroded. And the reason why, not a single piece of equipment was bonded in the equipment room. So it was basically eating everything from the inside out, all right? Because like I said, we added salt to the pool, that increased the connectivity of the water. They had nothing bonded properly, so there was a lot of electrolysis taking place in the water itself, and that's where you saw it, was right there in the equipment room. All right. Other issues. Sometimes what we hear is that, you know, I'm seeing salt build up on the walls, or I see salt on the steps. Well, keep in mind that salt, when it gets wet, dissolves very quickly. Okay, so if you see, you know, some kind of debris building up on your tie line, wet it. If it dissolves, it's salt. If it doesn't dissolve, it's calcium. Just as easy as that. Okay. And if you're seeing calcium buildup on your scale, on your tie line, check your saturation index, because I guarantee you that your water balance is incorrect. All right. Decks, copings, rock features. Is it due to salt or chlorine? Remember I talked about if you're using liquid chlorine and it spills out of the pool, the water evaporates, you're left with a high concentration of salt. Same thing with the salt system. When the water splashes out, you're going to be left with a high concentration of salt. So how does a salt system affect decks, copings, any kind of rock features? Well, the first thing is to keep in mind is that as water evaporates, the salt level does increase. So The solutions for those type of scenarios is make sure that you rinse off your decks periodically. So what you're doing is you're diluting out all the salt that may splash out of the pool. Seal the deck periodically. If you've got a very porous type of a deck, if you're using like flagstone or some of these pavers that are very porous, well, that water has a tendency to just percolate through and can cause corrosion, delamination, or damage to those types of soft stones. Either use a harder travertine that's much better for salt applications. Even poured concrete decks are going to be better than some of these softer paver stones as well. Did you know sodium hypochlorite adds salt to the pool? So in Florida, we see a lot of liquid chlorine pool maintained pools. And what you really don't hear is that people having deck issues with using liquid chlorine, whereas because it's a salt pool, it's like throwing spaghetti against the wall to see if it's good. Keep throwing it against the wall, see if that's what's causing the problems. Hey, it's a salt pool, and salt's causing all the problems with my pools. I'm here to tell you that salt system is just another way of making chlorine for a pool. You got to learn how to manage a salt pool properly. Okay, like in this case, if you get a lot of splash out, make sure you hose it off just to dilute down the salt concentration. Simple as that. We tend to get a lot of rain in Florida, so that does it naturally to dilute out the salt levels. All right, but if there's a deck that's real porous, make sure that they seal it. Make sure that they hose it off, because salt systems will cause additional problems to it. All right. Use compatible stone, seal periodically. As you can see in these two pictures here, water splashing out, it's going to create, pock marks. It's going to cause delamination in the stones itself. By properly sealing it, you can see the effects of the picture on the left where the water just saturates into the stone versus a sealed deck where it just bubbles up on the top. Ideally, the one picture on the right is what you want to see, is that it does not percolate down into the stone itself, and that's properly sealed stones. Okay, delamination, corrosion on a vinyl liner pool. Bottom right, you can see the kind of deterioration path of water. But here's the thing, and one thing I want to point out with that picture on the bottom right. Right, we think pool water, salt water creates problems. It's a rainwater gutter. So your rainwater, fresh water itself can cause damage with stone. It's water itself will cause problems. It's not because it's salt, right? How do you think this was carved out? Colorado River, right? You got water flow going through there. Niagara Falls, right? Fresh water. It's the water running through that's going to cause the erosion going through there. Look at the different dates and where the water level was, or where the edge of the waterfall was, right? So just constant water flow, erosion itself is going to eat away at the stone underneath it, okay? So I think that's it, Lauren. When we get into, other manufacturers of salt systems, like I said, I work with Autopilot. I can tell you anything you want to regarding Autopilot itself, but we're all operating the same way. You got a power supply, you've got a cell, you've got some kind of flow protection. You need salt, you need proper water temperatures, and you need proper flow going through there for the system to work properly, okay? When you're dealing with scale formation is the worst condition for a cell, and that's the reason why you want to go one step further with your water chemistry testing. Instead of just chlorine and pH, you want to make sure that you're checking for alkalinity, calcium hardness, water temperature, and the pH, and calculating and see what your saturation index is, okay? So salt generation system itself is not something that's complicated. It is a chlorine pool. You're just delivering the chlorine to the pool in a different manner than tablets, liquids, and granular. Okay.
Is there any questions for Sean right now that he may not have covered, something specific you want to know while we're here?
All right.
So I do want to say that.
I'm sorry, can I ask a question?
Sure, go ahead.
I actually only work commercial at this time. We just started doing residentials, and I'm about to go visit a saltwater pool. At least we believe it is. She had trouble describing how it works. And is there any equipment or anything that I need to purchase before I go out to work with that a little better? Is like you just said, it makes chlorine on the spot, and I always knew that, so I know I can just test chlorine like normal. But is there
Right.
anything I need to take with me that I probably wouldn't take with me to commercial pools?
Some kind of salt testing method. Salt
Okay,
strips. Yeah. All right. Because you do want to verify what the salt level is. A lot of times the salt system itself may tell you what the salt level is, but that may not be accurate. Such as like I'm going to pick on, certain manufacturers. With a Hayward system, it's going to give you an estimate of what the salt level is based on what the condition of the cell is. All right.
okay.
So if the cell is scaled up or if the cell is starting to wear out, it tends to tell you that you've got low salt. So if you've got a salt test strips, now in salt test strips, don't use the quick read. There's a AquaCheck Quantab salt test strip, and that takes anywhere from 4 minutes to 10 minutes to get a test result. But that's probably one of the more accurate salt strips that are out there.
Is there
There's
something?
also,
Oh,
go ahead.
is there something better to use over strips? Only because I know strips are. I mean, like if I'm going to use a Taylor test kit versus a strip, I'm going to take the Taylor kit. Is there something a higher step up than that, than just a strip I could use? Something I'm like, yep, this is what it is. Bottom line, boom.
Yes. A Taylor silver nitrate test kit is a salt tester. Very accurate.
Aren't there some digital test kits that you can get as well, Sean?
Yes.
That you can test the water where it's got probes and it'll give you a digital readout, kind of like a photometer or an electronic tester would do for pH and TDS and stuff.
With that, off the top of your head, are you aware if the Color Q test kit does that?
I believe they do test for salt. I can't tell you, affirmatively that they do or don't.
We picked up 3 of them last year, and I haven't ever tried to test for salt, so I don't even remember if that's in it. Thank you very much.
Absolutely.
Hey, Sean and Lauren.
Lauren,
Yes.
you're correct.
Hey, this is Bill Bailey. Last year I had a couple pools where my silver nitrate test for salt was inaccurate. It caused me problems. And Colin Taylor, they said if you have really high phosphates, that it will cause the silver nitrate to be inaccurate.
Okay.
Which it was. It was very so. Believe it or not, most of my salt systems are Hayward, and of course, troubleshooting a cell, they tend to cause the ppm of the salt level on the display to go bad, and so really we carry all 3. Because sometimes
the silver nitrate,
yeah,
without the impact of what you just shared with us on the phosphates, it is the most accurate one. I don't think we need to be that accurate in regards to what the salt level is. The meters, like Lauren, you were talking about, they're test salt meters. Some of those require periodic calibration. And after a while they wear out. In my opinion, it's not the most compact, but in my opinion, it's the most accurate, is that Myronell black box for salinity. Okay, it's a little black box, 9-volt battery. You put a water sample in the white cup and you press the button and it tells you what the salt level is. Like I said, in my opinion, that's the best one to use because it is accurate. You can calibrate it right there, but it's just not small and compact, right?
And like what you talked about, Bill, with the test kit, remember testing even regular water chemistry, there's test kit interferences that can happen so that you don't get those accurate results. And we know that like alkalinity and pH can be affected with the test kit interference due to high chlorine content. And then you have to figure out how to get around the interference. So I'm not sure if Taylor might have a workaround for that interference, or you just have to get those phosphate levels down and then have to retest after. Is there any other questions for Sean? There's a chat. Mike said, I know people that add a bag of salt every 6 months. If salt doesn't evaporate, then why would you be adding salt? So that's the question, Sean.
You'll be adding salt, like I said, as a result of bather splash out. If they've got a leak in the pool, depending on what type of filter that they have too. If they've got a DE or a sand filter, they're going to be losing salt out of the system. Okay, so on a closed pool where you don't lose any water at all, you should never have to add any kind of salt. But because of those other reasons, you're going to lose some of the salt. That's why you need to add salt back into the pool. And like I said before, if it's an outdoor pool, when you're adding salt, more than likely you're going to need to add stabilizer also. All right. Thanks for the question, Mike.
Any other questions for Sean while we have him here before he leaves us? If not, then our training has concluded. And I do want to say before you all leave that before I post this video on anything like social media, it will be edited to remove the things that whoever that rude person was earlier. We've all have heard Zoom and the security issues that they've had, even with school when they were using it for school, people popping up like that. It's very hard to control it because we don't have a lot of controls to be able to keep them out. I did end up having to lock the meeting. People complained about not being able to get into the training 20, 30 minutes in, but I think that eventually did it. But I will edit all those inappropriate things out. It may take me a couple weeks to post the training, Sean. Okay. But I'm going to have somebody edit out all those inappropriate things that popped up on the screen when we had to pause and say, hey, we're going to take all that out and try to make it like a professional training before I post it on YouTube or anything. Okay, guys? I know that I apologize for anything that was rude. I don't agree with people being that way. I don't know why people can't let people have professional trainings and be professional in the world, But I appreciate your professionalism and thank you for joining the training with me and Sean today. We really appreciate you all being here and taking part. And also for those that will be on the training, listening to it as a recording, we appreciate you guys as well. Thank you for what you do in the industry. You are essential workers, and that's why we want to provide training like this to you guys. And again, I'm with Space Coast Pool School for anybody who joined after the beginning part. So if you want any information, Sean is on social media very prominently with AquaCal. You can ask him questions, and I'm also on social media as well. So you can hit us up for any questions after the training is over at any time, I'm sure. Right, Sean?
Absolutely. And you all have my cell phone number, right? This first slide. If you need to call me, feel free to. Vincent, when you get out to the job, if you want to call me, feel free to, and I'll see what I can do to help you out with that commercial job.
And anytime you guys
I appreciate that.
And anything you guys need anytime in the future in general with water chemistry or anything else, I'm a CPO instructor. I used to work for the health department commercial in the state of Florida, but I can see what I can do to be of help or find the information for you because I know a lot of people in the industry. So always welcome to hear from you. I love this industry. It's a great industry to be in. So thank you very much, guys. And you guys have a wonderful day and enjoy the rest of your day and stay healthy and safe.
Thank you.
Thank you, Lauren and Sean. Appreciate your time.
Thank you very much.
Thank you very much.
Bye-bye.